Hello, today what we're going to learn about is how to use conditional statements in Python. I'm recording this video at 4 a.m., so sorry if I sound a little dead. Also, feel free to pause this video whenever you want because getting an intuitive sense of what is actually happening behind codes is very important. Before we talk about codes, what are conditions in the world we live in? Let's suppose that you're on a field trip to a car exhibition. You're with your classmates and teacher. Right now, you and your classmates are looking at this car. Then your teacher tells the students, if this car is red, take a picture of this car. If it's green, draw it on your notebook. Otherwise, take out your lunch. What would you do? Of course, you would take a picture of this car, because the car is red. Or we can approach this more logically. Condition that the car is red has evaluated to true, so you should take a picture of it. However, a condition that the car is green has evaluated to false, so you should not draw the car on your notebook. We don't even have to consider the otherwise statement, because we already have an action to do. What do you think about this car? It's neither red nor green, so you're neither taking a picture nor drawing on your notebook. You must take out your lunch because you have no other option provided. The reason why I use these examples is that real-life conditional statements work in the same way in computer science. According to Wikipedia, conditional statements in computer science are expressions that perform different computations or actions depending on whether a condition evaluates to true or false. Even the most complicated set of conditional statements would probably maintain the structure this way if whatever condition evaluates to true, perform a certain task. If condition 1 is false but condition 2, another condition, is true instead, perform another task. If none of them evaluates to true, perform the last task available. Let's apply this structure in Python by using if, elif, else keywords. If condition is true, perform a task. If our pseudocode or fake verbal code looks like this, in Python, its structure is if condition, enter, task. In order for the task to be performed, the condition must evaluate to true. Also make sure that the task part is indented or has 2 or 4 spaces at the beginning of a code line. It indicates the body block of the if statement. Given that a is a variable, let's say we want Python to print a to the console, only if a is greater than 3. In Python, it'll look like if a greater than 3, enter print a. But what will happen if integer 3 was previously assigned to variable a? Of course, 3 will not be printed because a greater than 3 has to evaluate to true to execute the print statement. What if we want to make some exceptions? In case the first condition doesn't work, we might need to provide different conditions that might possibly evaluate to true. Then we can use the elif keyword instead of the if keyword. Elif is an abbreviation of literal else if, which is only triggered when all the past conditions evaluate to false, and the present condition evaluates to true. Let's look at an example. We have a variable a with a value of 3. It looks like it prints string how only if a is greater than 3, which is false. So Python moves on to the next conditional statement, starting with elif. Elif a equals 3, print string r. By the way, in conditions, we use double equal signs to indicate an equation. The print statement is executed because a equals 3 evaluates to true, but the code has another elif statement. Unfortunately, the third conditional statement, no matter if it's true or not, is not even considered because the second one worked. What if none of these given conditions works? Then we use the else statement, which always evaluates to true without a specific condition. We can just use else for this. The last task with the else keyword will always be executed if every single past condition has evaluated to false. Let's look at an example. Let's say a is 3. The conditional statement beginning with if keyword evaluates to false. The second conditional statement literally says it's false. Since all the past conditional statements evaluate to false, the last condition beginning with else keyword evaluates to true. Executing the print statement, this code will print string u. Now let's talk about some inequality symbols. These are all the comparison operators you have to know. Pause the video and take some time memorizing them if you don't know them yet. Let's directly dive into examples. Here are some problems that have comparison operators. Pause the video and examine whether each statement results in true or false. The answer is false, true, false, true, false. The first statement says 3 is greater than 3, which is obviously false. The second statement says string hello is not equal to string hi, which is obviously true. The third one might look true, but it actually values to false because Python is comparing integer 456 and string 456, which are in completely different types. The fourth statement says 100 times 2, which is 200, is greater than or equal to 200. So it's true. The last statement is false because 600 is not less than 600. In fact, there are some ways to convert between type string and numbers like type integer or type float. They are called type conversion functions. Adding float parentheses in front of non-float data would return the decimal version of the data. Adding in parentheses in front of non-integer data will return the integer version of the data. Lastly, adding the string parentheses in front of non-string data will return the string version of the data. Let's look at the third example from the last slide. The original problem said integer 456 equals string 456, which evaluates to false. However, if we use int function on the right-hand side, both sides become integer 456, which evaluates to true. Same for the last one. By using stir function, we made both sides become string 456, which evaluates to true. The next thing I want to talk about is logical operators. We learned several types of data so far, like integers, strings, floats, but true and false are a type of Python data called Boolean. For example, you can literally assign Boolean true and false to random variables. But would you believe there are ways to conduct the operation of true and false? There are three so-called logical operators, AND, OR, and NOT. The AND operator requires both conditions to be true in order for the whole expression to evaluate to true. For example, true and true evaluates to true. False and false evaluates to false. True and false evaluates to false because, as I said, the expression is true only when both expressions are true. The OR operator requires at least one condition to be true in order for the whole expression to be true. Just like AND, true or true evaluates to true, and false or false evaluates to false. But true or false evaluates to true because it satisfies at least one condition. The last logical operator, NOT, basically negates the condition. Let's look at one example. Let's say a variable called variable has an integer value of 3. The first statement we see is variable greater than 3, which is false. And there's a logical operator, AND, because AND operator requires both conditions to be true. Without even looking at the next statement, we can tell that this whole condition will evaluate to false. Let's look at the next block, starting with elif. It says that variable less than 3, which evaluates to false. However, pay attention to NOT operator in front of it. What happens when you negate false? It evaluates to true. Thus, the print statement is triggered. What about the else block? We don't even need to consider about it because the previous conditional statement already evaluated to true. The last thing I want to talk about is input function. As developers, we sometimes need a tool to interact with users. This input function basically allows users to do a certain action and we can store that information. Here's an example. Age equals input typer age. Print your age is plus string age. So this code basically asks users to type age. If I type 17 to the console, for example, that number is stored in a variable called age. Since variable age is an integer, we have to convert it to string to concatenate it with other strings. So we use a stir function. Lastly, the console prints the entire text. Your age is 17. I want to give you a challenge that tests you on every concept we learned today. Here is the challenge. Thank you for listening. If you have any questions about today's lesson, then please email me at channinglee77@gmail.com. Bye-bye.